Hello, today we are going to talk about regression. Now, regression in machine learning, it's a technique that is used to predict a continuous outcome. Continuous outcome is a continuous number, essentially. For example, a person's salary or the price of a stock. Now, these are continuous outcome because it can have infinite values between even 0 to 1. We can have infinite values, right? 0.001 or 10 to the power minus 4, something like that. Now, in regression, we model a relationship between a set of input features and a target feature. For example, we consider the data set price of a house. We want to predict the price of a house. The features that we have is number of rooms and the size of the house, two features. I want to predict the price of a house based on these two features. So that's what we might use a regression model for. How we will fit the model with this data, we can talk about it later, but for now, regression algorithms, models, they're trained using historical data. And the goal is to find a model that can accurately predict the target, given these input features. Now, there are many kinds of regression algorithms. For example, linear regression, which is one of the most popular algorithms that is still used in many companies, even in production these days. Polynomial regression, lasso regression, ridge regression, etc., etc., etc. There are many complicated regression algorithms as well, and many simple ones like linear, like we talked about. Each algorithm that they are, each have their own strength and weakness, and in basically what we use, it typically depends on the kind of data we have, the quantity of data we have. If we have a very small number of data points, for example, 100 data points, what is the data point, by the way, in this case? Suppose that we are talking about price of the houses. Each of the data point will have number of rooms, for example, rooms and the size of the house. And the price target is the price of the house. Now let's consider about this. This is what the data will be. The data will have essentially one feature we can be, for example, some house is 2 rooms in it. Size is about 1,000 square feet. Price of the house is supposed $100,000. Right. Another data point can be again 3, suppose we have 3 rooms in the house, and then we have 2,000 square feet, and then something like 200,000, something like that. So each of these are data points. Now, linear regression model or any regression model is trained on features like 200, 3,2000, and it is trained to predict an outcome, continuous outcome like 100,000, something like that. So regression like this can be used in many areas of finance, economics, marketing, healthcare, etc., etc. For example, in finance, regression can be used to predict the stock prices. Now, in stock, we have many features, low, high, close, something like that. And then we can also use in healthcare for predicting the chance of a patient suffering from certain disease. Now we can have a feature for disease. What is the problem? What is the supposed red blood count? What is the white blood count? White blood cells count, something like that. So essentially, regression is a powerful technique that we can use that can help us understand how different factors influence a particular outcome and make a prediction about the future outcome. Let me share you an example now for a linear regression. Suppose we talked about this, that suppose we have 2 features in a linear regression, in a housing prediction, prices, size of the house, and the number of rooms in the house. The way linear regression, or in this case, linear regression has simple formula, y equal to mx plus c. M is the slope. So in this case, you can probably think slope is probably negative, right? Any line beside this y-axis will have a negative slope. We have negative slope, and then we have c is the intercept. This is where the y-axis is cutting. Now, suppose we have a new feature base. We have trained the model. How we have trained, we are not going to go into that today. But suppose we have this linear regression model, this line, which is the y equal to mx plus c. And suppose we want to predict the price for a new house that is not part of the data set. How will we do that? In that case, we will, let me give you, suppose the new house has somewhere around, on the side of the house, somewhere around here, okay? Number of rooms will be somewhere around here. So y will be equal to mx, slope is already predetermined, into x. X will be whatever the outcome, whatever these numbers are, and then plus c will be what we have decided earlier also. This essentially, x is basically features here, number of features. Y will use the predetermined slope and the predetermined coefficient for calculating the price of a new house that have these features. This is one example of how linear regression model might work. Likewise, we have many complicated algorithms. For example, random forest regression. It is one of the most popular regression algorithm. It is based upon decision trees. How decision trees work, it's pretty complicated topic. But these are very useful and very aggressively used model in many companies in production today. So that is very brief nutshell of what linear regression is. Thank you.